All right, when solving radical equations, you must always check for extraneous solutions. An extraneous solution is where your math is correct, but the answer does not work in the original equation. If there is no other solution, then we write the answer as no solution, or we can include the empty set. All right. So our goal here is to solve for our values of x. And if you notice here, I've got two of them, which is an interesting extra piece. So my first job is to isolate the radical sign. So I'm going to add 5 to each side. I end up with the square root of x plus 7 is equal to x plus 5. This is a square root, so in order to eliminate the square, I'm going to go ahead and take it to a power of 2. Now notice the parentheses here are so important, because while this simplifies easily to x plus 7, this is actually x plus 5 times x plus 5, which means you have to FOIL that into x squared. X times x is x squared. And then I've got 5x and another 5x for 10x. And then I've got 25. It's a quadratic, so we solve all quadratics by setting them equal to 0. I'm going to subtract x, and I'm going to subtract 7 to combine all my like terms. 0 is equal to x squared plus 9x, because I took 1 away, and then plus 18, because I took 7 away. Now we have to consider this as a quadratic that I can solve. Let's try by factoring. Two numbers that multiply to 18 and add to 9 sound like 6 and 3 to me. So x is going to be equal to, if 0 is equal to x plus 6, x is equal to negative 6. And if 0 is equal to x plus 3, then x is equal to negative 3. Now I need to put both those expressions into the calculator and see if that works. So I have the square root of, let's try negative 6 plus 7, and my parentheses, minus 5. My goal here is to get a negative 6 out. Uh-oh, I got a negative 4. Let's see this one. Take the square root of negative 3 plus 7 and my parentheses, minus 5, and see what that one gives us, negative 3. So when I substitute this one in, one works and one does not. When I'm doing my test, the square root of negative 6 plus 7 minus 5 equals, I was hoping that it would be equal to negative 6, and remember, it was equal to negative 4. So guess what? That one doesn't work. When I took the square root of negative 3 plus 7 minus 5, that one did equal to negative 3. So here's my answer. X has a value of negative 3. All right, let's talk about number 2. So number 2 is tricky because there's two radicals. I have a radical here and I have a radical here. So I'm going to solve this by putting one radical on each side of the equation. So I have the square root of 3x plus 2, and that 2 is inside the radical. And if I add 2 times root x to each side, it's going to be equal to 2 times the square root of x. Well, I'm allowed to, since their indexes match, multiply each side of the equation by itself, meaning I'm squaring each side. That's a property of equality. If I square root of something squared, that's going to be equal to that thing. Be careful of this one though, because this 2 times 2 is 4. Square root of something squared is equal to x. When I go to solve this, I'm going to subtract 3x from each side, and 2 is equal to x. Now I'm going to go ahead and do my check by plugging it back in. Does the square root of 3 times 2 plus 2 minus 2 times the square root of 2 equals 0? Let's go ahead and check it out. So we have the square root of 3 times 2 plus 2, we'll close that parentheses, minus 2 times the square root of 2. And yep, it equals 0, so it checks. So x is equal to 2 is a checked solution. If you're lazy and don't check your solutions, you run the risk of losing points by including ones that shouldn't be. Alright, let's take a look at this next one. I see this fraction exponent. Don't be nervous. Our first step was to rewrite it as a radical. So I have the cube root of x squared plus 15 is equal to 24. Now we need to go ahead and subtract 15 to isolate our radical. So I'll subtract 15 from each side. So the cube root of x squared is going to be equal to 9. 24 minus 15 is 9. Alright, our first step is to talk about this radical first. So what we're going to do is we're going to cube everything. We're going to take everything to the third power. These two operations are inverses. They cancel each other out. So all I'm left now with is an x squared is equal to 9 to the third power. So now that I have an exponent, I need to take the square root of each side. So x is equal to, and remember you have to be careful, remember your plus or minus. When I talk about 9 cubed, there I have 9 cubed. Remember, I'm looking for double factors. So here's 2 sets of 3 that can come out, 2 sets of 3 that can come out, 2 sets of 3 that can come out. So my answers are going to be plus or minus my 1, 2, 3 sets of 3. So that's 3 times 3 times 3. So x is equal to plus or minus 27. Now if you're unsure of that math, remember a lot of this can be done for you. I can take 9 to the third power, and then I can take the square root of 729, and then I can see that's equal to 27. So there's my value for x. Now when I go to check, remember I have 2 answers to check. I have to look at 27 to the 2/3 power plus 15 and see if that is equal to 24. So I'll take 27 to the parentheses 2 divided by 3 power, and then plus 15. I do get 24. That's good. That's what I'm looking for. So yep, that one works. Now let's talk about negative 27 to the 2/3 power plus 15 and see what that one is equal to. So we'll make sure we wrap it up in parentheses, negative 27 to the 2 divided by 3 power, and I want to add 15, and I'm hoping again for 24. There we go. Yep, that is equal to 24, so yes, that checks. Alright, so let's try this next one. My first step is to isolate my radical. So I can have x minus 8 to the 3/4 power is equal to 8. Now some of you might have thought, oh no, my first step should actually be to rewrite your rational exponent as a radical. Well, guess what? There's more than one way to do this problem. We're going to split this down this middle here and look at both ways. All right, so we have x minus 8, and that is going to be to the third power because I have the fourth root. This goes in my index, that goes on my power. All right, so what I need to do for the inverse of this fourth root is to go ahead and take this to the fourth power and take this to the fourth power. So I wind up with x minus 8 cubed, because these two radicals and exponents cancel out, is going to be equal to 8 to the fourth power. Notice I don't bother multiplying that out because I know I'm going to have to be doing some more math here. Now it's time for me to take the exponent and undo that by using the radical. So if you have a radical, the exponent will cancel it out. If you have an exponent, the radical will cancel out. So now I have just x minus 8. And I'm looking at the cube root of 8 to the fourth power. Well, I know that the cube root of 8 is 2, and that's going to be to the fourth power. So when I add 8 to each side, to the fourth power is 16. 16 plus 8 is equal to 24. And I can go ahead and do my check. I can go ahead and do my check by checking on 5 times 24 minus 8 to the 3/4 power and see if I get 40. So we'll go ahead and do that math. We'll do 5 times 24 minus 8 to the 3 divided by 4 power. Make sure this says a 4. Close my parens, and I get 40. So I'm good to go. All right, but I want you in your notes to have this other idea down. Sometimes it seems silly to be taking the square root and then the exponent and the root again, and we feel like we're doing an awful lot. So what I want you to consider is maybe this alternative. If I raise this expression to a power that is its inverse, so think about this for a minute. If I take this whole thing, what is the inverse of 3/4? We should go ask Keith Berkeley if he can help us. Because the power of a power is very powerful. So what I end up with here is x minus 8 to the first, which is just x minus 8. What do I end up with here? I end up with, check it out, it's right next door, the cube root of 8 to the 4th. If you have a calculator, you can go ahead and say, hey, what is 8 to the 4 divided by 3 power? Don't forget your parentheses if you have an older calculator. And you have 16 as an output. That's where we were way down here. When we add 8 to each side, we end up with x is equal to 24. So if this is confusing you, consider using your inverse, because exponents and radicals have that great relationship. Make sure your notes are neat, complete, correct, so you can use them as a reference.